Let's go ahead and continue on with a similar problem, but start to bring in a graph. Here are two equations. Each represents the relationship between the number of games, X, and the number of rides, Y, and the dollar amount a student is spending on games and rides at a different amusement park. All right, so notice that we have something kind of similar in both equations. We have an X and a Y that add up to a dollar amount. All right, let's take a look at that first equation, X plus Y equals 20. First question asks, what's the number of rides the student could get on if they don't play any games? On the coordinate plane, mark that point that represents the situation and label the point with its coordinates. All right, so if they don't play any games, all right, that means that the X value is 0. So if it's 0 games, that means X equals 0. Right, so if we're thinking about our point, it's going to have an X value of 0. All right, so then the question is, what would the Y value be? Well, if we put 0 in for X, think about what that means. So that would be 0 plus Y equals 20, which means that Y is equal to 20. So we're talking about if there's 0 games, that would mean 20 rides. So the coordinate 0, 20 would be a y-intercept coordinate. All right, right here, right? 0, 20. So let's label that 0, 20. And that represents 0 games and 20 rides. All right. Let's go on to number 2. What's the number of games that a student can play if they don't get on any rides? On the coordinate plane, mark the point that represents the situation and label the point with its coordinates. All right, so this time we're talking about 0 rides. And if we're talking about 0 rides, that means the Y value is 0. So if we're thinking about coordinates here, we're thinking about, all right, the Y value is 0, so then what is the X? So if we kind of think about that the same way, and this time we're going to put 0 in for Y. I'm just going to put that over on the side over here. So that would be X plus 0 equals 20, because 20 or 0 is going in for the Y value, which really means that X is equal to 20. All right. So in that case, we have 20 games if there are 0 rides. So 20, 0 would be your x-intercept over here. And again, that would be 20, 0, which represents 20 games and 0 rides. All right, let's draw a line that connects the 2 points that you have plotted. Let's see how good we are with this here. Okay, so there is our line. And remember, those 2 points are not the only 2 points that could represent this situation with the number of rides and the number of games that adds up to a total of $20. You could actually have an infinite amount of combinations, although in this situation, it's not really infinite because you really have whole number games and rides. So we're talking about, you know, the scale is by 2 here. So you could have something in between here that would still be a whole number, but really you've got a bunch of combinations here that would work for this situation. Like 10 games and 10 rides would add up to 20. 14 games and 6 rides would add up to 20. So you have a number of combinations that would work. But in order to graph a line, you need 2 points, and we had the 2 points at the beginning there, which were the y-intercept and the x-intercept, which we can often calculate more easily. So complete the sentences. If the student played no games, then they can get on 20 rides. And for every additional game that the student plays, X, the possible number of rides increases or decreases by blank. So notice our line is decreasing. All right, and we'll notice that every time the game goes up 1, the ride goes down 1. And we can see this too with our overall points here. So if we think about our overall situation here, we went over 20 and then we went down 20 between the y-intercept and the x-intercept. And if we divide those two like a rise over a run, so think about it, rise over run, we get negative 20 over 20, which is negative 1 over 1, which is negative 1. So every time that the games go up by 1, the number of rides then goes down by 1, decreases by 1. So the slope is negative 1. All right, so that's really what the question here is asking in number 5. What is the slope of your graph? Where does the graph intersect the vertical axis? So the slope of the graph, again, is going to be negative 1. Let's just write what we did up top there. So if we think of our rise over our run and take any 2 points on our graph, so if we took the first point and the last point, then we had a negative 20 for our rise here and a positive 20 for our run, which is equal to negative 1 over 1, or it's negative 1. You could do that same thing though for any 2 points. Like for instance, if we took these 2 points and looked at the rise over run between those, notice that we're going up by 4 for the run and down by 4 for the rise. And so if you're thinking about negative 4 over 4, that would still reduce to negative 1. Okay. The other question is, where does the graph intersect the vertical axis? Remember, the vertical axis is the y-axis. The vertical means up and down. So the y-intercept really is what this is asking for. And the y-intercept is 20. In other words, the point 0, 20.